Hello class, this is another tutorial on different examples, question tackling or concepts on class 2. So for this question, I was given the question by a student. So the question says the portion of the curve x equals to 2 over 3, y to the 3 over 2 between y is equals to 0 and y is equals to 3 is rotated about the x-axis. Find the area relating to the surface as it's being rotated. So as we said, I have a video on areas of surface of revolution. As you can see, it's being rotated, so it's surfaces of revolution. So it's being rotated on the x-axis. So at first I'll draw the graph. And I will try to show how it's being rotated. So I have my graph. This is my Cartesian plane. I'm going to show how the curve is being rotated. So I'm using this example because it has some small concepts on arc length and again surfaces of revolution. So check my video on arc length. Check my video on surfaces of revolution. So I'm told the portion of the curve. So as you can see, on my video on arc length, we said we have two curves where y is being given as a function of x, and again where x is being given as a function of y. Okay? So as you can see from here, it's x being given as a function of y, so automatically I'll be using this. It has a different formula for arc length. We saw that on the videos on arc length, how to derive that, so we saw that from there. So we'll use x as a function of g of y. So I'll try to draw this. So the portion, this is the graph. So the graph, something like that. It's being rotated on the x-axis. So it's something like that, for example. So assume this is the curve. Now the curve is x, okay, equals to 2 over 3y to the 3 over 2. Okay, so this is my curve. It's being rotated along the x-axis. So this is the axis of rotation. It's being rotated along the x-axis. So I'm trying to sketch y-axis. Okay? So once you rotate this, we'll get the similar portion on the other side. So it's something like that. So I'll try to draw it that way. For example, so after rotation, my expected graph will be, that's my expected graph once we have rotated on the x-axis. So we said on the x-axis, we said the formula for areas of surfaces of revolution, we said area equals to the integral. So placing the bounds from a to b, 2 pi, okay? Then we said 2 pi, what's our r? Our radius. It's now on the x-axis, our radius is the value of y, okay? Check my video on rotations of surface of revolution. This is our radius, okay? Our radius, when it's being rotated on the x-axis, our radius is the value of y. So our y is the value of, so it's just the same as r as a function of x multiplied by the arc length, L, the pi RL. So our arc length for this case, because we are using x as a function of y, okay, we'll say our arc length d of s is the same as the square root of 1 plus dx over dy squared. It's opposite to that, dy. So that's our formula. So we'll be multiplying by the square root of 1 plus dx over dy squared dy. Okay, so this is the area. So we'll get our area again as the integral from now. We are given this is the y value. Okay, this is the y value. This will be our y value. Remember, we said it's the integral from c to d, and we said our c is the y value. Again, here the y value. It's not the x value. For x as a function of g of y. So it will be our y value from 0 to 3. So it will be from 0 to 3, then 2 pi. But remember, 2 pi is a constant, so we'll take it outside the integral. So we'll get our area as 2 pi. Okay? What's r of x? R of x, I'll take it as y. Okay? The value of y. So this, okay, r of x is the value of y. So I'll say my y. Okay? It's the value of y here, remember? Multiplied by the square root of 1 plus dx dy. So let's compute our dx dy. What's our dx dy? So from here we said our x is the same as 2 over 3 y to the 3 over 2. So differentiating x to get our dx with respect to y, taking the power in front, so it will be 3 over 2 multiplied by 2 over 3, sorry. Okay, then multiply by y. Subtracting 1 there, I'll get just a half. So this goes with this goes with this. I'll get my dx as y second dy. So I'll get my dx over dy as the square root of y, sorry, as the square root of y alone. Square root of y. So that's my dy dx. So I'll be replacing dy dx with that. So I'll get the square root of y squared dy. Okay? My answer will be so I'll get my area to be 2 pi outside, the integral from 0 to 3 of y. Okay? Y is this value of x. Literally, usually say making x. Okay? Suppose I was told y is x cubed. I could have placed my x cubed here, but for now I'll be just placing my y to show my value of y. Because of our substitution, we have a method of substitution that requires this, so we won't be replacing that. So I'll get my y multiplied by the square root of 1 plus y, right? Multiplied by the square root of 1 plus y dy. It's with respect to y. So from there, I'll choose my u to be the expression inside the radical. So this goes with this, so I'll get my u to be 1 plus y. Okay? So from there, I'll get my du as simply dy. So I'll be replacing my dy with du, but now we'll be taking the integral from the y world to the u world. So from dy to du, we'll replace our 0 here, so we'll get our u for 0 will be 1 plus the value of y is 0, so it will be 1. Again, our y to the 3 will be 1 plus 3 to be 4. Okay? We'll be taking the integral, usually said to the u1, but literally it's where like replacing the bounds to be the same. I can say same face or what with the du, so I'll use my dy so I don't forget. So I'll get my area to be 2 pi the rad of, from now I've changed my bounds from 1 to 4, so it's 1 to 4 of y, but we said our u to be this, so our u, all this expression is u, so what's our y in terms of u? Our y in terms of u, it's u minus 1. So I'll get u minus 1, that's our y. Remember from here, I'll say, taking 1 to this other side, I'll get my y as u minus 1. So this is the value of y. So the value of y here, I'll take it as u minus 1, multiplied by the square root of, we said that the inside expression to be u, okay? Remember? So instead of dy, replace that with du, du. So I'll just write du. So from there we'll be able to compute that. So just clear this. So we will get our area. So let's open the bracket for that. So I'll write area equals to 2 pi, okay? The integral from 1 to 4, okay? U minus 1 raised to u to the half is just the same, du. So multiplying these inside, you add the power, so just simply adding the power, so it will be 2 pi, the integral from 1 to 4, okay? So this adding this will be u to the 3 over 2 minus u to the half du. Okay? So from there, performing the normal integration, we just add 1 to the power of, simply you can split the integral into 2. So let's split the integral into 2. So we'll say 2 pi, remember, multiplies everything, so it's 2 pi inside the integral of, I will say the integral from 1 to 4 of u to the 3 over 2 dx minus the integral from 1 again to 4, okay? Of u to the half du, sorry, it's not dx, just du. So I'll perform that. I'll say, so let's find this, the value for this. So the value of this will be add 1 to the power divided by the result of the power, so it will be u to the, it will be u adding 1, so this is same as 2 over 5, so it's 5 over 2, yes. So this is same as 5 over 2 divided by 5 over 2. But now placing the bounds, remember, placing the bounds from 1 to 4. So we'll be, we already cleared that. So that answer then will be minusing. Remember there's 2 over pi. We'll be multiplying that by the answer for this. So for this again, integrating this, we'll add 1 to the power divided by the result of the power, so it will be with minus. Now u to the 3 over 2 divided by 3 over 2. Again the bounds from 1 to 4. Okay? So performing that, I'll replace 4 to the u, so I'll get u to the 5 over 2 divided by 5 over 2. Sorry, u I'll be replacing it with 4. Sorry, so here it's just 4. Okay, divided by 5 over 2. Then I'll be minusing that with u now to the 1, so just same as 1 raised to 5 over 2 divided by 5 over 2. So this answer minus the answer from this other part, I'll get minus 4 to the 3 over 2 divided by 3 over 2 minus 1 to the 3 over 2 divided by 3 over 2. This answer will be, this is the same as the square root of 4 to the 5, so I just find my 4 raised to 5 4 raised to 5, it will be 4 raised to 5, so square root for that, 32 divided by 5 divided by 2.5, we'll get 12.8, so I'll get 12.8 minus 1 to the just 1 divided by 2.5 is just 2 over 5, so 2 divided by 5 same as 0.4. Okay, minus again, so this is just 4 cubed, so it's just 4 times 4 times 4. Square root of 64, it's 8, so 8 divided by 1.5, I'll get my answer as 5 rad. Okay, in integration usually write the fraction because of errors, and the error bounds are not error bounds, errors. So just 5 minus, this is just 1, it will be 2 over 3, so it's my minus 2 over 3. So from here I will get my answer as 12.8 minus 0.4, I'll get 12.4, okay, minus this, so this is the same as 16 over 3, so I'll just same as minus 14 over 3, okay, I'll get my answer as, so it's 16 over 3 minus 2 over 3, it's 14 over 3, so it will be 12.4 minus answer. I'll get my answer as 116 divided by 15. Okay, so that's my answer. So this is approximately the same as 7.733 for significant figures, yes. But don't forget, we have our 2 pi. So we'll be writing our 2 pi again. So final answer will be area equals to 2 pi multiplied by 7.733. We'll get 2 pi, what's our pi is that, multiplied by 2. So our 2 pi multiplied by 7.733. My final answer will be 48.59, approximately there. We are talking of areas of surfaces of revolution, so it will be squared units. So this is our final answer. So from there, I'll be uploading another video to solve different questions on Calculus 2. So this is a video incorporating arc length and areas of surface of revolution. It's from the University of Nairobi. Don't forget to like, share, and subscribe. It's Lee Professor.